Recently, there has been a lot of buzz in the biocircle about spiders. The reason could be this discovery, the world's largest spider web. But what makes this new find so remarkable is not just its size but several jaw-dropping reasons that have scientists scratching their heads. This massive web was found in an ecosystem completely devoid of sunlight and built by unique chemical spiders. Even more surprising, it showcases a rare phenomenon where solitary spiders exhibit communal behavior. The discovery happened in 2022 when Czech cave club explorers stumbled upon a stunning spider city in a cave near the Albanian-Greek border. The web is located about 50 meters from the entrance and stretches along narrow, low-ceilinged passages, covering an area of 106 square meters, that is roughly equivalent to a 32 square meter apartment filled with over 100,000 spiders. But here's where it gets interesting. This isn't just any cave. It is a sulfur cave formed by sulfuric acid rather than water erosion. The cave is rich in hydrogen sulfide due to geothermal activity, making the environment highly acidic and toxic for most life forms. Yet, there are over 100,000 spiders along with other arthropods like centipedes and beetles. Without sunlight, what powers this ecosystem? Scientists were baffled until they discovered a mysterious sticky substance on cave walls. Under the microscope, it turned out to be sulfur, oxidizing bacteria that convert toxic hydrogen sulfide into energy and organic carbon, sustaining life in total darkness. Another key player is the midge, which feeds off these bacteria and forms the base of the food chain, supporting spiders and other arthropods. This unique relationship makes this cave one of the earliest known terrestrial ecosystems completely dependent on chemical energy rather than sunlight. Hence, it is often referred to as a chemical spider city. Before diving into more details about these fascinating creatures, let's take a quick break for our featured video, The Weight of the Soul 21 grams. Do you believe in souls? Scientists have attempted to prove their existence through scientific methods, and one researcher measured weight changes at death. Surprisingly, he concluded that the soul weighs exactly 21 grams. Another scientist placed objects high up in hospitals to test near-death experiences, with some patients accurately describing them upon recovery. If you want to know more about these experiments and what scientists think about souls, check out our video link above. Back to our topic, many people don't realize for the scientist who discovered this spider web, what was most surprising wasn't its size, but rather its internal composition. It is not made by a single species, but by two different types of spiders, about 69,000 Tigonaria domestica and 42,000 Prinerogon vagans. This discovery is unprecedented. Why? First off, Tigonaria domestica, or pengju, are common house spiders with a body length between 6 to 12 centimeters. They often appear in dark corners of human houses, basements, and warehouses. These spiders belong to the funnel web spider family, known for their funnel-shaped webs. Their hunting method involves hiding inside these funnels and attacking prey that triggers vibrations on the web's entrance. This makes them highly efficient predators in dimly lit, confined spaces. However, they are solitary creatures, each web belonging exclusively to a single individual. They are territorial against both other spiders and their own kind. Intruders are often driven away or attacked. The second spider species is Prinerogon vagans, or wander pig, which is widely distributed in Europe. These small spiders with bodies measuring 2 to 4 mm typically weave thin, irregular sheet webs. Under normal circumstances, wander pigs would be preyed upon by pengju and other larger spiders. But inside the sulfur cave, something unusual happened. Solitary pengju not only gathered on one large web, but also shared it with an incredible number of wander pigs. In the outside world, wander pigs avoid larger spider webs to reduce attack risks. Inside the cave, however, they coexist peacefully with pengju. This phenomenon challenges previous scientific understanding of spiders' solitary behavior. What caused this change? Researchers have some theories. First, there is an astonishing number of insects in the cave, about 2.4 million. These form dense clouds around spider webs, providing a constant food source for spiders. With abundant food, their motivation to hunt other spiders decreases. Moreover, these insect swarms are confined to specific areas within the cave due to particular temperature and humidity conditions. This makes those spots highly desirable for all spiders. To access the richest food resources, they prefer densely sharing one large web rather than moving to less favorable locations. Additionally, this massive spider web is exceptionally thick, like a blanket, offering easy hiding places deep inside when threatened. It is a unique safety benefit of communal webs. Furthermore, the cave's permanent darkness might be key to these spiders coexisting peacefully. In total blackness, they rely more on web vibrations than sight for prey detection. This dark environment also affects their gut microbiomes and reproductive rates due to limited food variety and harsher conditions outside. So, in summary, this spider community isn't suddenly evolving into social spiders, but rather the cave's unique resource distribution is forcing solitary species to form colonies. It's a world where sunlight isn't needed. Chemical energy sustains the largest known spider web. However, there is an interesting debate online about whether these spiders truly evolved from solitary to communal due to the cave environment. This question makes sense because over 99% of spider species are solitary, with only around 20 to 30 zoospatial species globally. Less than 1%. Even after this incredible discovery, scientists haven't classified the spiders on the world's largest web as rare social spiders. Why, for example, Anelasimus eximius, a red spider from South America that we call social Anna pig, is considered one of the representative communal spiders by researchers. Despite weaving large webs together like cave pengju, social Anna pigs are still classified differently due to their unique characteristics and behaviors. Usually there are hundreds to thousands of spiders in a group. In extreme cases, it can reach tens of thousands, making them one of the largest known social spider colonies. But what is different about the cave pengju? In the cave, each pengju mostly stays on its own funnel web within a giant shared web, like having an apartment in a building. However, Anju spiders are different. Their webs aren't made up of individual webs but rather large sheet-like structures and tangled support threads, acting as a super organ. Different areas of the web serve various functions. The outer part intercepts prey, while the center is for feeding, nurturing young, resting, etc. The entire spider web acts like a communal home instead of private territory. When damage occurs, any individual will join in to repair it and maintain their space. In contrast, when a cave pengju feels vibrations on its web, each one goes out alone to hunt. But Anju spiders work together like ants, coordinating hunts for large flying insects caught in the jungle. Webs, since their webs aren't sticky enough, prey often escapes, so these small spiders swarm and capture them before they can flee. During this process, there are specialized roles. Frontline spiders take risks first, silk-type spiders wrap up prey to weaken it, and wing removal-type spiders drag the prey into the web's core. These roles aren't fixed. Each spider takes on different tasks randomly during hunts. After hunting, they share food without adult spiders driving away young ones. Sometimes adults even give way for younger spiders to eat. This contrasts sharply with solitary spiders where young might be eaten if they get too close. This selfless behavior also extends to nurturing others, offspring, a rare trait in spiders. Adult Anju spiders care for all the young regardless of who they belong to. Such cooperative parenting is typical only in truly permanent social species. Unlike the cave pengju's independent coexistence, Anju form true family-like colonies. But why do less than 1% of spider populations evolve this way? It has much to do with their tropical rainforest habitat. Their ancestors were solitary but faced challenges, scarce food and large flying insects appearing unpredictably in clusters. This pushed these small spiders towards group living. Group hunting allows them to tackle prey larger than themselves, increasing survival chances. For newly hatched spiders, leaving the nest is risky. They might be hunted by ants or starve if unable to find a suitable habitat. Staying together ensures safety and food security. Thus, under these pressures, some small rainforest-dwelling species evolved long long-term stable social structures like those of ants. Looking back at that giant web in the dark cave, it is not just about solitary spiders becoming social. It is about desperate predators adapting to survive by living together in darkness. Isn't this fascinating?